Alrighty students, so to start out in this video, we want to look at the new topic for this unit, which is waves. So kind of what I want you to be thinking of is, what are waves? Why are they special? Why are we talking about this? Probably heard of different waves before, waves on the beach, sound waves, light waves, different things like that, but why does it get a whole topic in science? That might seem like, why are they special? So let's take a look at why we care about waves. The main reason that waves is an important topic is that waves are one of two ways to transfer energy. And you guys know a ton about energy. We just finished a whole unit on energy. Waves are one of two ways to transfer energy. So let's look at what those two ways are. There's particles and there's waves. Now, just saying the word doesn't mean you understand it. So let's look a little closer. What do we mean by particles? Energy transferred as a particle. I've got three examples here we're going to look at. When we look at this bowling scenario, you'll notice that there's energy present in the bowler, and that energy reaches the end of the lane. And the question is, how did the energy get there? Well, the answer is pretty obvious. It's the bowling ball, right? It's an actual object. The bowling ball is the particle that carries energy from the bowler to the end. In this next one with the slingshot, we have a similar scenario. There's energy present in the shooter. That energy reaches the target, but how does it get there? Well, the particle. The particle is the marble that's shot by the slingshot. It's a physical object that carries that kinetic energy from the shooter to the target. And lastly, in this demolition example, we'll see the same idea again. When this wrecking ball smashes the building, it's like, how did the energy get from the crane, the machine, over to the building? Well, it was a particle that traveled that distance. It was the wrecking ball that took kinetic energy and smashed the building. So the key idea when we're talking about energy transferred as a particle is that it's some kind of object that carries energy as kinetic energy of the object traveling from one location to another to do its work. Waves are a different way of transferring energy, right? Waves are where energy is transferred when an object doesn't just go all the way from the source to the receiver. So let's look at this first example. This isn't technically a specific scientific wave, but I think it gets the point across nicely. In this example of dominoes, there's energy in the first little flick to knock the first domino over, and then that energy reaches the last domino. Well, it's like, how did it get there? It wasn't really one single object that traveled that whole distance. What traveled that whole distance is really the energy, and the energy was passed from one domino to the next in a succession of collisions. That's really getting a little closer to what a wave is. So let's look more specifically. What do we mean by waves specifically? There are two main types of waves. There's matter waves and electromagnetic waves. A matter wave is a disturbance or oscillation that travels through a medium. And what we mean by medium is just some kind of material. So that could be air, it could be water, it could be a slinky spring. There's tons of mediums. And what do we mean by electromagnetic waves is a disturbance or oscillation, this time not traveling through a medium, but oscillations of electric and magnetic field. It makes them kind of special. All right, let's look at the different kinds of matter waves first here. There are two main types of matter waves, transverse and longitudinal. In these animations, you'll see what defines the difference. In a transverse wave, the particles of the medium are moving perpendicular to the direction of the wave energy. So in this animation, the particles are moving up and down, but the wave energy is moving from left to right. In the compression or longitudinal wave, you'll see that the particles are moving parallel to the direction of the wave energy. So in this animation, the particles are moving left and right, and the wave itself, the energy, is being transferred from left to right. There are other more complex kinds of waves where it's kind of a combination of transverse and longitudinal, or there can be twisting that's involved, but these are the two key categories of matter waves. When we look at electromagnetic waves have this kind of special difference because they are oscillations of electric and magnetic field. This little animation shows how we imagine that working, that the electric and magnetic field oscillate at 90 degrees to one another, and these fields travel together as kind of a single thing, single oscillation of electromagnetism. There's an entire spectrum of different kinds of electromagnetic waves depending on the frequency and wavelength. This image shows the different kinds of electromagnetic waves ranging from radio waves all the way up to gamma rays. You'll notice that visible light is actually a tiny little sliver of the electromagnetic spectrum, and we'll come back to this later in this unit, but light, the way we see with our eyes, is actually due to electromagnetic waves. All right, so again, two main types of waves, matter waves and electromagnetic waves. But the main idea for all waves is its energy transfer that's not due to a single particle or group of particles moving from one place to another. It's somehow energy traveling from one place to another, either through a medium or as electric and magnetic field. Either way, waves have specific traits and specific characteristics that we have names for. So all waves have a wavelength. Wavelength is the length of a full cycle. This would be measured in something like meters in the metric system. Notice in the images at the bottom you can see how wavelength is measured there. Amplitude is the deflection from rest position. If we think about a matter wave like a slinky, if you disturb the slinky has a preferred rest position, and then the disturbance causes it to move from that. So however far it moves would be its amplitude. The velocity is a simple one. We talked about that in Unit 4. Velocity is speed and direction. So velocity of a wave is just speed and direction of the wave energy. This would be in units like meters per second. And lastly, frequency. Frequency is the number of wave cycles passing a location every second. The units for that would be waves per second, or there's a special unit for this waves per second term called hertz. Now these animations that are just appearing on the right are an easier way to see this concept of velocity and frequency. Velocity implies that something is moving. In a wave, what's moving is energy. So in this animation, you can see the velocity of the wave, the movement of the energy from one place to another. It's also nice to see frequency in this animation. So we can see two different frequencies here. The number of waves that are passing a location per second is different depending on how frequent the oscillations are. Okay, bringing it back to the very beginning, how do waves fit in? Why are they important? Because they are just one of two ways to transfer energy, either particle or wave. Now you know a little more about them and the entire topic of waves, and we'll go much deeper into all the different little aspects of waves. We'll be kind of starting with matter waves and how that transitions into sound. Then we'll talk a little bit more about the electromagnetic spectrum and light, and that will lead us into some astronomy. It should be awesome. Hope you're excited to learn more about waves.